Welcome to the second unit of ATS 113. Our first lecture is going to be about pressure in the atmosphere, which is the first part of Chapter 4, pages 92 to 100. We actually are going to talk about this in more detail than the text does, but the text is going to provide a good overview, and I want to highlight some particularly important concepts, and that way you'll be particularly prepared for class. In particular, this first figure in Chapter 4, again, we're going to spend much more time and much more detail about this kind of result, but I want you to definitely, by the time we're done with the lecture, understand what's going on in Figure 1. Also, in this section labeled the concept of pressure, the book kind of quickly moves over different units of pressure. We're going to spend quite a bit of time on this in class. We're actually going to talk about 4 different units of pressure, as I have notated here: pounds per square inch, inches of mercury, pascals, and millibars. Make sure you understand these 4 concepts of ways to express the pressure of the atmosphere. Your book here talks a little bit about Dalton's law. We actually talk about Dalton's law in a slightly different context when we're doing moisture, but this is actually a good introduction to it, and I'm going to adjust my lectures accordingly. So make sure you understand the concept of Dalton's law. Also, we're going to talk about different ways of expressing, thinking about pressure in the atmosphere. One thing we're going to talk about is how pressure is the weight of the air above you. But that often gives students the misconception that pressure only works down, that like gravity, just like gravity pulls down, pressure is only in the down direction. This paragraph that I have highlighted here will help you understand why that's not correct. So make sure you grasp that concept about how pressure works in all directions equally. We're going to talk in more detail in the book here about the concepts of how pressure and density change with height, but make sure you understand the discussion in the text, and in particular the figure at the bottom of page 95 it's incredibly important. This text box here on the top of page 96, I'm going to work on the assumption that you already know about things like velocity and acceleration, these basic physical concepts. On the other hand, if you don't, from high school physics or something like that, please do read over that. At the bottom of page 96, we're going to start talking about the equation of state, or better known as the ideal gas law. This is one of the few equations that we bother learning in this class. We generally don't work with equations in here. So obviously it must be important, so make sure you really understand what's going on in this section of the book. This is just a continuation of that same text box. I really want to highlight here at the bottom of page 97 this paragraph that is explaining about the trickiness of the relationship between pressure, temperature, and density through the ideal gas law. Students make this mistake all the time, and I'm very good at writing questions that measure whether or not you understood this concept. So make sure you get it down and you'll be in great shape. And finally, the last 3 pages of the reading are just different instruments we use to measure pressure. We're going to talk about mercury barometers and the different adjustments you have to make to mercury barometers for various reasons. We're going to talk a little bit about the effective density here. And then aneroid barometers and the instrument that our aneroid barometer is often hooked up to, called a barograph. Okay, this is a pretty short, straightforward reading. We'll actually probably get through more material than this in class today, but that's no problem. Just make sure you understand this stuff, and if you have any questions, please contact me by email or audio blog or whatever it takes. This has been Dr. John Truggy, copyright 2006.